I'm Dr. Johnson, and you're at Bridgeport Elementary, and you're about to meet my first grade explorers, and they're going to learn about the types of soil with Mr. Rick Crosslin.
Hey, that was a great introduction, explorers. I love that. We're going to explore types of soil. And if you remember what we've been talking about, soil is different everywhere because plants and animals are different everywhere. And if you're here in Indiana and a tree dies, that tree lands on the ground, and what happens to that tree? Yes.
It decomposes.
It decomposes. Everybody say that word.
Decomposes.
So it decomposes. So depending on what type of plants or animals are different places, our soil can be all different types. And so let's take a closer look at some of the different types of soils. All right? So what we're going to talk about today is a soil called loam. Loam? Everybody say loam.
Loam.
Loam soil. Another type is
Silt. Clay.
clay. And our third type we're going to investigate is sand. Sandy soil, clay soil, and loam soil. Let's take a closer look at that. Okay, so I brought some different soil samples from all over the world. And one of them we're going to look at is called, well, let's just see, it's called loam. Check out loam. It's kind of what you could, from a scientist standpoint, what color is it? Whoops. It's slippery. Well, let's listen to it. Look at the size of the particles. And when I shake it, okay, there's loam. And then this one over here is, read that for me. What does it say?
Clay.
There's some clay. And right now we see some differences already, don't you?
Yeah, they're different colors.
Different colors. And what about the size of the particles?
They're different colors.
Let's see if it sounds different. Listen to this one. Ready? Listen. Listen to this
They
one.
sound different.
Well, we don't know yet. Ready? Here's this one. Here's this one. They do sound a little bit different. Yeah. They look different. So here is loam. Here is clay.
And we need one more.
One more. Let's look at, oh, what's that one say?
Sandy.
And listen to this one. And so we have different colors. So these came from different parts of the world. We have clay, loam, and sand. Now, if we mix two of these together, like clay and loam, what will we get? Well, we get this right here. We get clay loam soil. See that? Yeah, those are mixed together. And if we mixed sand and loam, guess what we get?
Sandy loam.
Sandy loam. So soil is a mixture of different things. Now, you guys mentioned silt. Here's some silt. And this is peat. When you made your worm farms, you used peat, which is a plant. When a plant dies and gets in the soil, this is a soil called peat. And here's my favorite one. Look at this one. Look at the name of this soil.
Muck.
Muck. Muck. That just sounds like muck. It sounds like yuck. This soil, when it gets wet, is really sticky. So we're going to explore some different soils. But before we do that, we have some tools. Would you show us the hand lens? Where's the hand lens? This one right here. Here's our hand lens. And the hand lens has two lenses, a big one and a small one. And you have to focus it. Let's see. Take a look. Check out my thumb. What does it do to my thumb?
It looks really big.
Really big. So this is a tool or an instrument that helps does it help our nose?
No.
Our ears?
No.
Our tongue?
No.
Our fingers?
No.
What does it help?
Eyes.
And eyes. Okay, look at that small lens and tell me, this is scary. What do you see?
It looks really smallish. It looks really smallish.
It make it bigger and small. This is a hand lens. We're going to study soil with that. We also have a pipette and some water. Let's show them how this works, okay? Take this. It's got air in it now. Put it down inside of the water. Push it and push the air out. Let go. And it sucks the water up. Do some drops. How's a drop? That's called a pipette. Everybody say pipette.
Pipette.
Pipette. Go ahead. It's kind of like a heart beating. Now this is a cool instrument. It's called a graduated, because it has numbers on it, And what's this shape?
A cylinder.
I saw you guys studying shapes before I came in here. I'm so impressed. This is a graduated, which means has marks on it, cylinder. Now, there, that says what number right there?
100.
100. Is that 100 bananas?
No.
Is that 100 miles?
No.
It's 100 ml. Does anybody know what ml stands for?
Millimeters.
No, that's mm. But good. mm is millimeters. Sorry, dude. What do you think? mm is millimeters. mg is milligram. But what is ml? Anybody know?
Milli-inches.
That'd be mi. I like your thinking. Wrong, but I like it. What do you think?
Milliliters.
Milliliters. How'd you know that?
Easy. I learned.
Easy. You learn. Everybody say milliliter.
Milliliter.
Here's how I like to remember. Milla is a Latin word like Italian. Milla means 1,000 baby flowers. And milla means divide by 1,000. So this is everybody say it like this. A milliliter.
Milliliter.
I have to more like a liter.
Milliliter.
So this is ml, which stands for milliliter. Say it.
Milliliter.
Now, my friend, I want you to pour this liquid into here and pour it to 50 milliliters.
Milliliter.
Not bananas. So go ahead and pour some in there. Let's use the cup first.
All the way to 50?
All the way to 50. You guys tell him when to stop. Use the cup first. No, the cup. Just pour it in there. And we'll use this to get it perfect. Move your book. Be careful. Dun, dun, dun. Here we go. Dun, 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 dun. Tell me when to stop. Tell him when to stop. He's at, what number is he at now? Stop. Let's see what he has. He's at, wait a minute, he's at 46, 47, what? Milliliters. So you got close. Use this to get up to 50. Okay, so you got 47. If you put too much, use that. If you need more, here he goes. Come on, put that in there. Tell me what is that? Squirt in there. What is that now? 48. A little bit more. Stop. Look, how many does you have in there?
50.
I'll show it to the camera to make sure this is true. Would you say, Dr. Johnson, that's 50? Would you say that's 50?
It is definitely.
You're killing me with the music in the background, but we like the music in the background, don't we?
Yes.
All right, start wiggling to the music. Hey, why don't you guys wiggle on back to your seats and pour 50 milliliters. Go ahead. Pour 50. You have to do that over again.
According to that, but in reality.
There. Okay.
Is that exactly 50?
I don't.
Hey, explorers, let everyone hold up their 50 milliliters.
And what tool did you guys use? What's it called? Graduated cylinder. Okay. In front of you, you have 3 soil samples. Point to the clay, point to the loam, point to the sand. Okay, what I'd like you to do now is take your 2 fingers and feel the sand that's on the plate. On the plate, there's a little sample right there. What does it feel like?
It feels soft.
Feels soft. All right.
And smooth.
Now feel the loam. What does the loam feel like?
No.
The loam.
Hard and sandy.
Okay. Now feel the clay. What does the clay feel like?
A little too. Oh,
It's crunchy and hard, right?
it's spiky. It's crunchy and hard. But the loam and sandy are not that much hard.
They're not that hard. They're softer.
Yeah, a little. Yeah.
Who would like to share something about how it feels? Yes, dear.
So this clay is hard, and this clay is soft.
And that clay has what? How is that picture of that clay that's soft? What does it have in it that you?
It has water, rocks.
And water. And your clay does not, does it?
Yeah.
No. All right. Who else would like to share? Yes.
This is long, and long is it's like on a big place.
So loam is like in a giant field. It's good for farming. Who else would like to share something?
Clay soil is sticky. Clay Sandy soil is different colors. Clay soil is soft. Clay soil is smooth. Some clay can be red, and you can play with clay.
So some clay can be red.
Deeper layers of soil has more rocks in them. I have topsoil, clay soil, sandy soil, and bedrock in that order.
That's true, and you made that drawing in that order. So what's at the very bottom, you think, of the soil?
Bedrock.
Bedrock. All right, so here's what we're going to do. I got a question for you. We have 3 soil types. They're different colors. They feel different. You've already tested them, right?
Yes.
And you've done some research about how they are different, right?
Yes.
But here's what I need to know. I need to know if water goes through them the same. So we have 3 different types. And on our worksheet here, we're going to pour 50 milliliters through one of these. And I put some holes in the bottom of these cups. And we're going to see how long it takes the water to go through one of these. And so right here on your paper it says water drip times. How much water? 50 milliliters, right?
Yeah.
So you're going to write 50 milliliters on each one of those. And we're going to time sandy soil, clay soil, loam soil. Which one should we do first?
Sandy.
Are you sure?
Yeah.
Okay. We might do well, let's try the loam first. So I'm going to just use a cup, and you got 50 milliliters, right? Here's how I'm going to do this. I'm going to say, on your mark, don't do it yet, I'm going to describe it. Would you move back just a little bit, sweetheart? Hold that cup for me. On your mark, get set, pour. And then I'm going to go 1, 2, 3. And when you start to see drips, that's how many seconds you write down. You understand? So if I pour and it goes 1, 2, 3, drip, 4, 5, drip, you would know when yours was either 3 or 4, right? It might be 20. It might be 80. Which one do you think is going to hold more water?
Clay.
What do you think? Well, we don't know. Clay, you think so?
Clay.
But see, we're going to use science and evidence. We're going to see. So if clay is more, that should be a bigger number, right? What do you think? Which one's going to go fastest? Let's just do a practice. Here we go. I'm going to say on your mark, get set, and you guys say pour. On your mark, get set, pour. I'm going to pour it all. 1001, 1002, 1003, 1004, 1005, 1006, 1007. I'm not spelling it. 1008, 1009, 1010, 2011, 2013, 14, 15, 16, 17. Is there a hole in the bottom of that? 18, 19. Can you see a hole in the bottom of it?
Yes.
19, 20, 21, 22, 23, 24.
Stop. 24.
Oh, 24 seconds. You see the first drop at 24? So that took 24 seconds. Now, you want to be careful. You don't want to pour so much like this that it goes over the side. Would that be a fair test? No. Don't drip it over the side. Yes, yes?
Yes.
Yeah, you're going to have to add 50 more milliliters, my friend. Milliliters. Do me a favor, come over here.
It's dripping.
And let's do it next with the sand. All right, so we did loam, and that was 24 seconds, right?
Yes.
Do you think sand is going to be longer, the same, or shorter? Predict.
Shorter.
Really? Show me with your prediction. Nobody thinks it's going to be longer? Nobody thinks it's going to be the same? You all think it's going to be short. Well, let's test it. Are you ready? You want to hold the cup here? Hold this right here. Try not to get water everywhere. I'm teasing. Here we go. Ready? This is sand, and you guys think it's going to be shorter, so less than 24. I got 50 milliliters, right?
Milliliters.
On the count of 3, 1, 2, 3. You guys say, I'll go 3, 2, 1. You guys say pour. Ready? 3, 2, 1.
Pour.
Tell me when. Start counting. 1001, 1002,
1002.
It was 1002. 2 seconds. So I'd write 2 seconds. I think we've discovered something here. But you know what? Scientists test it over and over again. So how about we have you guys test this? Are you ready for it?
Yeah.
Well, let's take a closer look. Okay, so here's what I'm going to do. In one hand, hold the clay. In the other hand, hold the graduated cylinder. The graduated cylinder, not the water, young man, the graduated cylinder. Okay, you ready? And I'm going to say, hold this over your plate. Hold it over your plate. It's your clay over the clay section. You have your 50 milliliters on the count of 3, 2, 1, pour. 1001, 1002, 1003, 1004, 1005, 1006, 1007, 2008, 2009, 2010, 33. Anybody still going? 34, 35, 36, 37, 38, 49, 50. Still going? 52. 53. Clay must really hold the water. Got it? All right. That was 59 seconds. In one hand, hold the loam soil. In the other hand, hold the 50 milliliters of water. Are you ready?
Yes.
Yes, yes. Are you ready?
Yes.
I'm going to count 3, 2, 1 and say pour, and then I'm going to start counting, and you write down the number when yours drips. Here we go. 3, 2, 1, pour. 1001, 1002, 1003, 1004, hold it up. 1005, 1006, look for drips. 7, hold it up. 8, 9, 10, whatever number drips, write it down. 11, 12,
Oh, mine stopped.
13, 14, yours was 13, 16, 17, 18, 19, 20. Anybody still not dripped? 22. Oh, you saw drips. 23. 24. 25. 26. 27. 28. 32. 33, and we'll stop on 33. All right, so you see your chart. Mine looks like this. I have my soils, sandy, clay, and loam. The water, we put 50 milliliters, 50 milliliters, 50 milliliters. And this is interesting. My clay took a long time, over 60 seconds. My loam was 33 seconds. Now, we have one more to test, which is the sand. What do you think? Is the number going to be higher or lower than these numbers? Well, that's your prediction. We need some evidence. So let's do one more experiment. Get 50 milliliters of water in your graduated cylinder, and let's try it with sand. Okay, we have the sand in front of us. Hold it over the plate. 50 milliliters. 3, 2, 1, pour. 1001, 1002, 1003, 1004, 2005, 2006, 7, 8, 9. Wow, everybody's done on 1002?
Yeah.
1001? The results are in. Sand really goes flying. Water goes right through it. Record your answer.
There, I'm already done.
Explorers. Today with Mr. Crosslin, we've learned a lot about the 3 different types of soil. And our writing assignment today is going to be that you're going to pick 2 of the soils and you're going to compare and contrast. And when we compare, we're going to say ways in which they are what?
Different.
Compare is different?
Same.
The same. And when we contrast, we're going to say ways in which they are different. That is going to be our writing assignment today, after we make our record on our worksheet. And let's thank Mr. Crosslin for coming and making science come alive in our classroom.
Thank you. Thank you, Mr. Cross. Covered in soil.